All right, so welcome to the Phidgets webinar covering the Getting Started Kit with C#. So if you're new to Phidgets, Phidgets are programmable USB sensors used by STEM professionals and students across the world. So the tools you get in the classroom are the same as the tools used in a professional environment. So Phidgets education is currently targeted towards grade 9 to 12 students with some basic coding knowledge, including loops, conditionals, as well as some knowledge of arrays and methods. Phidgets work with Mac and PC. Currently, they are not working on Chromebooks, but we're hoping to have that coming soon. So in this webinar, we're going to be covering the Getting Started Kit, which you can see right here, and the introductory course with C#. So to get started, you want to navigate to fidgets.com/education. I'll just highlight that there. fidgets.com/education. So this is our the main home screen of our education website. As you'll notice, there's a few different tabs here: Learn, Educators By, News, and Contact. All of your webinars will be listed under News, so the recording of this webinar will be under that News tab, and any webinars coming up will be there. Educators tab, you'll see some teacher resources. We will be adding some new resources in the coming weeks to help you get started with Phidgets and use Phidgets within your classroom. But today we're going to be looking at Learn. So Learn is the real hub for where your students all the information your students need is really in this Learn tab. So you'll notice a few different options. So what are Phidgets? Explains the basics of Phidgets and some applications. It's a really great primer for your students, even as a take-home assignment just before you get going. It's a really great resource just to understand why students are using these products and where they're used in the real world, just to give that context, that they aren't just using a toy, that they're using something that a professional would use, and that it's knowledge that they can take with them into their post-secondary or professional lives. The next will be Getting Started, so that's what we'll be covering today. Then device tutorials. So device tutorials reviews some of the individual Phidgets. So for example, the thumbstick Phidget, as you can see here in my video, or the spatial. So these are individual courses. If you're interested in learning more, there are webinars going over the individual sensors and those device tutorials. They include a code sample, an application section so students can learn about where they're being used in the real world, along with a practice problem. The next section is projects. So projects is where things like your rover kit will live. So there's a course that goes along with the rover kit, along with some extension projects with the rover kit, as well as there's projects that go along with individual devices. For example, there's a project with the light sensor, which is used to track phone screen time. So it's good if you have some kids who are on their phones a lot. It's a great assignment to provide a checkup on phone use, and to a little bit more to learn. There's also a security project with the Sonar Phidget, and some more projects with the Getting Started Kit, so you can use the Getting Started Kit more going forward. But like I said, today we're going to be starting that Getting Started Kit. So we'll go to the Getting Started Kit. So the Getting Started Kit consists of 2 LEDs and 2 buttons, along with a Humidity Phidget. The Getting Started Kit is really recommended for anyone using Phidgets, just to learn the basics of the Phidgets code. So to get started in the Getting Started Kit, you can also, there's a the website on the side of your getting started box will be fidgets.com/start. If you just want to send students directly to the getting started kit, they can go directly to this page that I'm on right now. Sorry, I lost my mouse. Here we go. All right. So the first thing you'll want to do when you navigate to this page is set my language and environment. So if you've watched any of the previous tutorials, you'll notice that this Windows Mac OS wasn't present, so we've added that in now. As you can see, Windows, you can use Java, Python, or C in a number of different coding environments. So for Java, you can use NetBeans or Eclipse, Python, Thonny, PyScript, or PyCharm, C#, Visual Studios. If you click Mac OS, you can see you can use Java, Python, or Swift. So we're continuously making improvements to the website, so we love to hear feedback about anything you would like to see or hear from us. So today I'm going to be walking through the Windows C# Visual Studios path. If you're interested in Visual Studios or Visual Studio, you can go to visualstudio.microsoft.com/downloads, and there is a free community version, which is the version we're going to be using today. So once we've selected our operating system, our language, and our development environment, we're going to select Done. So after we select this once on the website, now all of the information displayed on the website will be in that C# language. So you only have to select it once, your website will remember it, and it will be displayed in the top corner of your screen. So if students are having any issues with their code, it's a good first place to start to check up on, to make sure that students can or have selected the correct language. So right now, we're not going to go through the build kit, which would be the second step. However, I'll just quickly show you what that looks like. So it goes step by step through those build instructions with pictures to show each step. So you assemble the buttons, then you add your LEDs. Then you connect your Vint hub. So the Vint hub is a real important piece of the Phidgets equipment. As you can see here, there's different port numbers, and we'll actually use those port numbers in the code. So these steps are very important for the assembly process. Then we add that humidity fidget onto our getting started kit. So after we've assembled the kit, it'll look something like this. Handy Fidget will be Velcro to your kit. Then we get to the configuring the development environment. So I'm actually just going to walk you through the configure section in Visual Studios. So the first thing we want to do is create a new project. Then we'll see project templates. You'll want to go to the console app in C# and create a new project. We'll call this project Getting Started. And create. All right, then we have our project created. So after we create our project, we'll have to add the Fidgets library. So the Fidget library gives you access to all the Fidgets code and tools. So to do this, we're going to do a NuGet install. Just get back to the screen. So we're going to right click on our project and we're going to go to Manage NuGet Packages. And we're going to browse and search for Fidget 22. So we'll want to install this fidget22.net. So we click on it and install. So once it's installed, you'll see this coming up. All right, and now we're ready to get going with Fidgets. So that's your simple configure steps. As you can see, it's not complicated. You don't need to install anything extra on the student's computer. It's all through Visual Studio. There's no install on the computer. So again, we have the steps, each with pictures to follow along, and a troubleshooting section at the very end. So again, if there's any issues, this is your first line of defense. And then we finish. So with that, the initial setup of Fidgets is complete, and the initial setup of your Getting Started kit is complete. So now we get into the real meat of the course. So you'll see there's 3 different sections after the setup. So there's a simple Fidget setup, which is where students learn to use their LEDs and buttons. There's a smart Fidget setup, which is where you learn to use your humidity fidget. It looks something like that, humidity fidget. And then a final challenge, in which case students incorporate all the components together to build a mock thermostat. So we'll start with the blink LED. So each lesson in Fidgets consists of 4 main components. So there's going to be a GIF showing students what they can expect from their code. There's going to be a code sample, which gives students a baseline lesson for what they see in the GIF. Next, you're going to have a practice section, which really gets students to dive into that code, modify it, understand what that code is doing. And finally, a troubleshooting section to create some student independence so they can go through the initial errors that may occur on their own. So this includes things like checking to make sure your Fidgets are plugged in properly, or for example, the LED flashes quite quick on this. So just some baseline first line checks. So let's take a look at this code sample. So we're going to copy this code sample and we are going to paste it into our Visual Studio. All right, so then I'll get you to look up at my video here as I run this program. So you'll see the LED flash on and off. I'll run that again, just because it's sometimes hard to see. See on and off. So that's your first basic Fidgets program, is that LED. As you can see in the code, each line is commented. So students can hover over these comments to learn what each line of the code is doing. So all Fidgets programs have the basic flow. So the first thing in each Fidgets program you'll do is add the Fidgets library. So that's at using Fidgets 22. That just gives you access to all of the API and all the code that goes into Fidgets. Next, you will want to create an object in your software to represent your LED. So in this case, an LED is a digital output object. It provides a voltage from the Vint hub to power your LED. So that's creating a representation for your physical fidget in your software. Next, you'll want to address. So this is what differentiates as a simple fidget. So address is looking at that hub port number on your Vint hub. So your Vint hub is numbered on the top and the bottom. So that hub port is which port your fidget is plugged into, and then setting the hub port device to true. Again, that's a trait of a simple fidget. So basically we're creating a software object to represent our physical fidget, and then we're telling where our software where to find that fidget. So after that, we're going to have to open a communication channel between that software and that fidget. So in this case, we call the open command. So it can take a second of time to locate or to create that connection between your code and that fidget. So we do put in a wait time of 1000 milliseconds in that open call, just to give your program a little bit of time. If you do not put that in, you can get errors trying to use your fidgets before they're connected. Next, you're going to use your fidgets. So here we're turning the LED on, which is setting the state to true. We are adding a sleep timer of 1 second or 1000 milliseconds to keep that LED on for that second. And then we're turning the LED off before our program completes. So we add that sleep timer in again to keep that command running. If you leave that command out, the LED won't be visible. So then students go into their practice problems to dive into that code sample. So things like modify your code so the LED stays on for 2 seconds. Again, students have to go into the code and find what keeps the LED on for 1 second or 2 seconds or 3 seconds. Then we have flash your LED on and off 3 times. So again, figuring out what code turns the LED on, turns the LED off. And then finally, modify your code to flash the green LED hint address. So again, students have to go into that address, realizing it's the port number that in fact controls which LED we have access to, rather than the color or the variable name. It is that address section. So after that, students have completed their first basic Fidget program. Then we move on to lesson 2. So lesson 2 will be reviewing the button. Again, you'll see an LED showing students what to expect when their program runs, a code sample again, a practice section, and a troubleshooting section. Let's take a look at this code. So again, we just copy and paste it into that program. And we run our code. Just let me move this window over here. So as you can see, the button state is false. If I press down on the button, the output will change to true. False when it's released, true when it is pressed. So again, this code, we are importing the library. We are creating an object to represent that red button. So in this case, it's a digital input object. We are addressing that object. Again, looking at our Vint hub to see where that button is plugged in and setting that hub port device to true. Again, creating that object, telling that object where to find the fidget, And then we are opening that object, creating that communication channel with that 1 second, 1 second pause, just to let everything connect. And then we're going to be using our Phidgets. So in this case, we're using a polling method to gather data from our Phidget. So that's going to be a method that's used throughout the basics of the Getting Started course. So the loop will continue forever. It will check the state of the button and print it, so red button.state. And then we're going to have a bit of a sleep timer just to keep the amount of information that students are seeing and the amount that the loop is checking the button at a reasonable rate. So students explore the polling method and that loop and that sleep timer in their first practice question, which is modify the loop to repeat every 10 milliseconds, 1,000 milliseconds, and 5,000 milliseconds to see how that changes the responsiveness of their program. So just getting a handle on that polling method. Next, we're going to see what the state of the green button is, again, reinforcing that address section and how we find our Phidgets. Next, we're going to modify the code to only print when the button state changes. So this is a really important practice question, which will be used throughout the rest of the course. It is a challenging question for students. So it is one that you may get questions about. We do have solutions for all of our programming on Phidgets Education. We do not post those solutions. However, if you email us, we would be happy to send them your way. We just don't want students to be able to find them. But again, this is, again, a very essential question going forward, and it is more of a challenge for students, and it tests their coding skills, it tests their problem solving skills. Once again, we have that troubleshooting section to give students some independence in this course. Then we move on to lesson 3. So lesson 3 is combining the 2 types of Phidgets. So your 2 LEDs and your 2 buttons. As you can see, there's a GIF showing what students can expect from their code. Again, a code sample, some practice problems, and that troubleshooting section. So we'll check out this code. Copy it in. Right, we'll copy that in. And we'll run that code. So if you look at my window up at the top corner, you'll see when I press the red button, the red LED comes on. When I press the green button, the green LED comes on. We're just using our Phidgets together now. Whenever we're using Phidgets, we'll want to make sure we stop our program before we start a new program. So that's a really common error that happens with students. Phidgets can only be used by one program at a time. So if students are getting kind of some strange errors coming up when they're trying to run their code, check to make sure there's no other code running or using their Phidgets first. So we'll stop that program. And again, take a look at that code. So again, we're importing that library, bringing that library in. We're creating objects for each of our Phidgets. So in this case, there's 4 of them, 2 buttons, 2 LEDs, 2 digital input, 2 digital output. Next, we will want to address each one of those objects. So again, setting that hub port number, looking at where they're plugged in on the Event Hub, and telling our program where to find our Phidgets. Next, we will want to open each of those objects. Again, having that wait time for each connection. Then we'll be using our Phidgets, using that polling method once again. So again, cycling through, checking to see what the red button state is, and setting the appropriate LEDs. Same with the green button. So getting those loops and conditionals in the student's practice. So the practice section of this code is really focusing on the customizable nature of Phidgets. So for example, the first one, modify your code so the LED turns off when the button is pressed and turns on when the button is released. Modify your code so the green button controls the red LED, the red button controls that green LED. Again, just getting students to understand that the variable names don't connect the Phidgets, the colors don't connect the Phidgets, as we're forming those connections in our code, meaning that we can have multiple possibilities of how we combine our Phidgets. Lastly, again, is more of a challenging question. So modify your code to count the total number of button presses. So again, we're using that practice problem knowledge we gained from lesson 2 to come into lesson 3 to count those button presses. Once again, we have a troubleshooting section, again, going over the basic errors that can occur, just to give students, again, that independence to go through this course. So with that, lesson 1 to 3 is complete, and we come across our first practice challenge. So our first practice is a tug of war. So it's a game where you count the button presses, and whoever reaches 10 button presses first is the winner, and there's some LED flashes that go along with that. Again, most of this code is done in previous practice problems. So this is really an application section, a problem solving section where you're applying what you've learned into a new program. So taking those practice problems where you counted the button presses and bringing them into a new context. It also provides a great check-in moment for you as a teacher, a great gradable assignment, just to see where students are at before they continue on deeper into that course. And it's a fun activity to try out and to show off to friends. So with that, our button and our LED learning sections are complete. So students know the basics about their buttons and their LEDs. And we're going to move on to our smart Phidgets. So most Phidgets students encounter will be smart Phidgets. Generally, they look something like this, a nice black box with some white print on it. Here's your light sensor. This was the sonar sensor, thumbstick Phidget, things like that. And the getting started kit, we're giving the humidity Phidget. So the first lesson in our smart Phidgets is how to read the temperature from a humidity Phidget. So once again, we start off with that GIF. Then we have our code sample. Now, the first thing you'll probably notice about this code sample is it looks a lot simpler than the Simple Phidgets code sample, and it's a lot shorter. So if we look at the code sample, you'll notice there's no longer an address section. So smart Phidgets, you don't need to address in most situations. So when they connect to a VinTab, they'll initiate that communication process telling your program where to find them. So you don't have to worry about addressing with the smart Phidget. So let's look at this code. All right, so we copy and paste our code in again, and we run. Guys, we'll get to learn how warm it is in my current location. So as you can see, our temperature is printing out. If you want to manipulate the temperature to see how the sensor works, you can have your students hold their Phidget. So as you can see, my temperature is going up slightly because it's so warm in my room. It won't be quite as dramatic. There we go. We got it up to 27 degrees. You can also blow on the Phidget. However, right now we are not recommending that for obvious reasons. So again, hold on that Phidget to see what's happening. Again, we want to stop our program before we continue moving on to our next code sample because we will get errors if there's a continuous use of Phidgets. So we stop that program. Let's take a look at that code again. So once again, we're importing that Fidgets library. We are creating our object. So in this case, it's a temperature sensor object. We don't need to address because it's a smart fidget. Then we're going to open our temperature sensor. Again, we need that wait time to let the software object connect to our physical fidget. Then we're going to use our fidget, again, using that polling method of the infinite loop, checking what the temperature is. So again, we get our temperature with temperature sensor dot temperature. And again, having that sleep time just to keep our loop at a reasonable pace. Then we have a practice section here. So this is more of a practical practice, especially for those in the States or students who may be more used to Fahrenheit, different applications for different units. So we convert our Celsius output, which is the default output for the temperature sensor, to Fahrenheit. Once again, we have that troubleshooting section going through common errors. So then we're on actually our last lesson of our Getting Started course, which is to read temperature and humidity using our humidity fidget. So again, let's copy that code. Paste it in. And let's see what our output looks like here. So as you can see, we have both the humidity and the temperature being printed. Again, if you want to see a quick change in results, you can hold on to that humidity fidget. You'll notice the humidity goes up quite quickly, along with the temperature. Holding it in my hand. Again, you can also blow on it. We're not recommending that at that time or at this time. And we stop our program. So taking a look at this code again, we have adding our library. So that's always the first thing you need to do. Next, we create our objects. So in this case, we have 2 sensors to 1 fidget. So some fidgets have more than 1 sensor in them, which makes them a great value and a great device to look. So temperature and humidity pairs really well together. That's why they're both in this sensor. So one fidget can create more than 1 object. So we have to create an object for both of those sensors. Then we don't need to address again because it is a smart fidget. Then we open both of those objects. So we have to open both the humidity sensor and the temperature sensor separately, even though they are part of 1 fidget. Again, having that wait time. Then we use our fidgets, again with that polling method. We'll print out both the humidity and the temperature. And again, that sleep time just to keep our polling at a reasonable rate. Then we get into our practice section. So this practice is more focused on students' coding skills and using that input with the data they get from the sensor in their code. So in this case, it's only printing the humidity if it's above 30%, or only printing the temperature if it's above 21 degrees Celsius or 70 degrees Fahrenheit. So again, we're just getting students to engage with that code, understand where their data is coming from and how to manipulate that data in their programs. Once again, we have troubleshooting section just to give students, again, that first line defense if something isn't quite right with their coding. And with that, all of our basic Fidgets lessons are completed, and we're going to move on to our Smart Fidget Practice Challenge. So our Smart Fidget Practice Challenge uses the humidity fidget and our LEDs. So we have to take some of what we've learned from our simple fidgets and what we've learned from our smart fidgets to create a hot or cold indicator. So basically, if the temperature is between 20 degrees and 24 degrees Celsius, the green LED turns on. If it's outside that range, the red LED turns on, as well as we output the temperature to our user so they can see what that temperature is. So once again, similar to the last practice challenge at Tug of War, we've actually completed a lot of the individual pieces of this practice challenge in our previous lesson practice. So for example, in lesson 5, we checked if the temperature was above or below, I believe it was 20 degrees. So in this case, we're just adding in, turning on those LEDs with that basic practice. So again, we're getting students problem solving, we're getting students in the code, and really trying to get students active as quickly as possible, rather than spending a lot of time going through large explorations. We want students to really get their hands dirty quickly with this course. So with that, we've completed the simple fidgets and the smart fidgets, and we actually know how to use our entire Getting Started kit now. So with that, we move on to our final practice challenge. So our final practice challenge is to build a mock thermostat. So we use our thermostat to set temperatures, to increase and decrease the temperature, as well as indicate if the temperature is within 2 degrees of what we've set. So students, again, have actually completed most of this project in previous practice. So again, they're just bringing in the pieces that they've learned to just practice their problem solving skills, rather than generating whole new code. Students can grab bits and pieces and just put them together into a real application. So things like every time the user presses the green button, increase the temperature by 1. So we've actually completed this in lesson 3, when students had to count their button presses. So again, it's just taking that practice problem and putting it into a real context, which is really what we want to do with Phidgets, is again, get students into code quickly, get students problem solving, and get students into their creativity quickly. We have some troubleshooting again. And with that, we're finished our Getting Started course. So again, it's lots of practice for students, lots of engagement for students. They get their code and they get into the code really quickly to be able to have fun. Now, if you want to do more with the Getting Started kit, there are more practice, more projects in the project section. So things like different games, turning this into a stopwatch, things like that. So the course doesn't stop with the final challenge. You can continue to use your Getting Started kit. In fact, you can even disassemble your Getting Started kit and use the components in different ways. So a common, if you're using C#, we do have a Unity tutorial. So a lot of students end up using their Getting Started kit as a game controller. So that Unity tutorial is really great if you're using Unity in your class with C#. Otherwise, here are your Getting Started kit projects. If you're interested in purchasing the Getting Started kit, you want to select this Buy tab. So it'll give you all the information about the Getting Started kit. It's a great deal at $18 US or $25 Canadian. There's also the Rover kit and a few Phidgets devices. So these are the Phidgets devices that are supported by tutorials at this point in time. You also have access to all of the other Phidgets at Fidgets.com at a 40% discount if you purchase a class set of Getting Started kit. So that's really a a great deal and a great opportunity to, again, explore. So we've had teachers use the Getting Started Kit both in the classroom and as a take-home activity with distance learning with great success. So whether it's in class or out of classroom time, the course really is a great independent activity for students who get to explore a different component of computer science. So rather than always being a screen and keyboard input, they do get to engage with that real world, and again, using a real world tool. So with that, I'll just wrap up a little bit. So if you're interested in purchasing a Fidget, again, you'll want to check out that Buy tab. And if you have any questions, please contact us at education@fidgets.com and check out the news tab for any upcoming webinars or for this recording of the webinar. Thanks everyone for coming, and have a lovely day.